So logarithmic function. So let me define what it is first. Logarithmic function is the inverse of exponential functions. And exponential functions come up in real life when things are increasing really quickly. Typically that's where they're used. Something increases really quickly versus logarithmic, the whole kind of where this comes up with the purpose of this. Logarithmic is talking about something that increases really slowly. So, and we'll look at that in a little bit when we graph logarithmic functions. But for now, let's just kind of get used to what it looks like, what it means. So if we have an exponential equation, I'm going to kind of compare an exponential equation, a little abbreviating here, with a logarithmic equation. Okay, so when we have an exponential equation, it might be something like x equals b to the y power, which I know right now that might look funny because we've been doing b to the x power more, but remember back when we did inverses, we swapped the x and the y. So, I mean, if we had started out with an exponential, y equals b to the x, we're switching x and y, so that when we write the inverse function, it's going to make more sense. So if x equals b to the y is the exponential equation, then the corresponding logarithmic equation would be log base b of x equals y, or y equals log base b of x. Okay, so that is the corresponding logarithmic equation. Now, to make this make a little more sense, let's put some numbers in. Blue. So let's say we have 4 to the third power. We know that that is 64. Okay, since 4 to the third power is 64, let's replace each part in the logarithmic equation that goes with it. So my base was 4. So that's log base 4. My x was 64. So if we were just given this log base 4 of 64, I'll tell you why in a minute, but our answer would be 3. Okay, so equals y, the exponent is 3. So and how I read this is log base 4 of 64. Log base 4 of 64. Or just log base 4 of 64. So what it really means is it's saying 4 to what power is 64? That's the question. So if I didn't know the 3, and I didn't know the 3 was there, I'm trying to figure out 4 to what power gets me 64. Okay? So let's start with the fresh one. How about log base 2 of 32? So this is saying 2 to what power is 5? 2 to what power is 5? 2 to what power? Sorry, I just gave you the answer. 2 to what power is 32? 2 to what power is 32? Is the question. The answer is going to be 5. Okay, 2 to what power is 32? So if I rewrite this as an exponential equation, it would be 32 equals 2 to what power? And we just did solving exponential equation, so we know what we would do is we change 32 to 2 to the 5 power. And since we have the same base, I get x equals 5. Okay, now there's going to be an easier way to do this when we're given a logarithm though, but that's kind of how it relates with the exponential. Okay, so the answer to simplifying log base 232 is going to be 5. So let's do a couple more, but before that I'm going to give you a property. logarithmic property. And these are listed in the book on 9.5. It's one of the ones in the book in section 9.5, properties of logarithms. The one we're going to focus on to do simplifying is that log base b of b to the x power is x. Well, let's redo the one we just did real quick. We had done log base 2 of 32. Remember, we're trying to figure out 32 is 2 to what power? Or 2 to what power is 32? So what we would do is we would rewrite 32 as 2 to the 5th power so that these b's line up. Whatever the base is, 2, you want to write the number as 2 to some power. So now what happens is the log base 2 and the 2 cancel out, and we just get 5. It drops out to just get whatever the exponent is. So log base 2 of 2 to the 5th power is 5. How about log base 3 of 81? Log base 3 of 81. So I want to rewrite this. 81 needs to be written as 3 to some power, since my base is 3. So 3 to what power gets me 81? It's 4. So this simplifies to 4. Let's do one more kind of simple one. Log base 5 of 25. Hopefully you're starting to get the hang of this, and you can just look at that and know, okay, that's going to be 2. Because 25 is 5 squared. So log base 5 drops out, and I'm just left with my exponent of 2. Let's do 2 more. These ones are a little trickier. Log base 3 of 1/9. Okay, so this one's a little trickier. Could do this a few ways, but I think the easiest way, I know that 9, I'm going to have to somehow turn this into 3 to some power. So before I do anything, I'm going to rewrite 9 as 3 squared. Now, I know that I can move that 3 to the 2nd power up into the numerator and make the exponent a -2. So now my answer is going to be just -2. Okay, so you might need to use a little bit of your exponent rules there. Okay, last one. Log base 4 of 1. Log base 4 of 1. Now this one's a little tricky, but let's think, is there any way I can change this to 4 to some power? Remember, anything to the 0 power is always 1, so this works out. Replace 1 with 4 to the 0. To get 0. So that would simplify to 0. And this is actually a property, one of those properties I was referring to. It's another one of them. Log base b of 1 equals 0 always. No matter what the base is, if you're doing log base b of any number, of 1, doesn't matter what the base is, the answer is always going to be 0.